Lesson 1: Understanding the Basics, the simplest Spring Boot precursor. Introduction. Hello everyone, and welcome to our first lesson. Before we can run, we must first learn to walk. And before we dive into the simplicity of Spring Boot, it's crucial to understand the powerful engine that drives it, the Spring framework. Imagine building a large, complex application in the early 2000s using Java. You'd have many different components. A component to handle web requests, another to talk to the database, a third to process business logic. In a traditional approach, these components create and manage each other directly. For example, your business logic component might create a new database connection object every time it needs one. This sounds simple, but it creates a tangled web of dependencies. It's like every part of your car's engine is permanently welded to every other part. If you need to change the spark plugs, you have to take the whole engine apart. This is called tight coupling, and it makes applications brittle, difficult to test, and a nightmare to maintain. Can anyone think of a problem with an object creating another object directly inside itself? The Spring framework, created by Rod Johnson, proposed a radical new idea to solve this problem. The idea was simple but profound. What if, instead of components creating their dependencies, an external entity created and gave them what they needed? This is the principle of inversion of control, or IOC. Think of it this way. Without IOC, you go to the library, search for a book, find it on the shelf, and bring it to the checkout counter. You control the entire process. With IOC, you go to the librarian, tell them which book you need, and they go and get it for you. The control of finding the book has been inverted. It's now the librarian's responsibility, not yours. In Spring, this librarian is called the IOC container, or sometimes the application context. It's a central part of the framework that manages the lifecycle of your application's components. You tell the container what components you have, and how they relate to each other, and the container takes care of creating them, wiring them together, and managing them. So, how does the container give the components what they need? This mechanism is called dependency injection, or DI. It's the practical application of the IOC principle. Instead of your business logic object creating a database object, you simply declare that it needs a database object. The Spring container sees this declaration and injects or provides a ready-to-use database object when it creates your business logic object. It's like building with Legos. Instead of manufacturing each brick yourself, you just declare, I need a 2x4 red brick here, and the Lego system, the container, provides it for you. This makes your components loosely coupled. They don't need to know how to create their dependencies, only what they are. The objects that are managed by the Spring IOC container, the ones it creates and wires together, are called Spring beans. A bean is just a regular Java object, but its lifecycle is managed by Spring. Your services, your data access objects, your controllers. In a Spring application, these are all typically managed as beans. So, to summarize, the Spring framework was created to manage complexity in large applications. It does this through inversion of control, where the framework manages the lifecycle of objects, not the objects themselves. The practical technique for this is dependency injection, where the framework provides dependencies to an object instead of the object creating them. The core of this system is the IOC container, and the objects it manages are called beans. This approach leads to loosely coupled code, which is easier to test, maintain, and evolve. Now that we have these foundational concepts, let's see them in action. In the guided practice, you'll use an AI assistant to build a very simple Java application without Spring, to feel the pain of tight coupling. Then, you'll rebuild it with the Spring framework to see firsthand how dependency injection simplifies everything. You won't be using Spring Boot just yet. This exercise is about appreciating the core Spring framework first. Learning goal. This first lesson introduces the core concept of a Java application structure and why frameworks like Spring Boot exist. We'll analyze a very small console program that prints a message, but which is intentionally written without any Spring Boot magic. By the end, students will understand the structure of a basic Java application, the concept of tight coupling and why it's a problem, how this simple app becomes the foundation for learning dependency injection later with Spring. 1. Project Structure Overview. This first project is our starting point. It's a very small Java project that doesn't use any frameworks yet. The purpose is to understand the basic structure of a Java application before introducing Spring Boot. Inside the repository, we have only a few files: the Maven configuration file called pom.xml, and 2 Java classes inside a package named com.example.demo. Those 2 classes are called main application and message service. Even though the project name includes Spring Boot, there is actually no Spring Boot here yet. This project is the before picture, a way to see what plain Java looks like before frameworks start doing the work for us automatically. 2. The message service class. The message service is a simple example of what we call a service in software development, a small component that performs a specific task. In this case, it has one very simple responsibility: to return a text message. It doesn't connect to a database or any external system. It just returns a hard-coded sentence. We call this kind of class a plain old Java object, or POJO. It doesn't depend on anything external, and it doesn't use any annotations or frameworks. Even though it seems trivial, this little class helps us understand how services are designed: one class, one clear purpose. 3. The main application class. The main application is the starting point of the program. Every Java program begins its execution with something called the main method, and that's exactly what this class contains. When the program starts, the Java virtual machine calls this main method automatically. Inside, the application creates a new instance of the message service and then calls its method to get a message. Finally, it prints that message on the screen. If you run this program, you'll simply see the words "Hello, World" displayed in the console. It's the most basic example possible, and that's exactly the point. We're starting from zero to understand the building blocks. 4. Why this design matters. At first, this design looks perfectly fine. It's simple, direct, and works exactly as expected. But it hides an important lesson about software architecture, and that's the concept of tight coupling. In this example, the main application directly depends on the message service. It creates it manually, using the new keyword. This means that if we ever wanted to change how messages are produced, for example, to read them from a file or a database, we would have to modify the main application itself. That's not flexible. It makes our code harder to maintain, harder to test, and harder to reuse. So, even though this project runs fine, it demonstrates a design limitation that becomes critical as software grows. This is why frameworks like Spring were created, to help us remove tight coupling by introducing something called dependency injection. That's the main lesson here: understanding the problem before learning the solution. 5. The pom.xml file. Now, let's look at the Maven configuration file. Maven is the tool that manages how our Java project is built and what libraries it depends on. In this case, the configuration is minimal. It simply defines the project name, version, and the fact that it uses Java 17. There are no dependencies yet, which means it's a pure Java project. No frameworks, no external libraries. It also includes a small plugin that allows us to run the program directly from Maven, without having to manually locate compiled files. This setup helps us focus purely on the logic, not on the build process. 6. Running the project. To run the application, you simply use a Maven command that compiles and executes the program. Once you do that, the console will show one line of text, "Hello, world." That's the entire behavior of the application. It may look extremely simple, but it's the foundation for understanding what happens under the hood when we later move into Spring Boot. This step allows you to see clearly where the main method lives, how the code executes, and what happens before Spring Boot automates all of it. 7. Key takeaways for students. Let's summarize the main ideas you should remember from this lesson. First, every Java program starts with a main method. That's where execution begins. Second, a service class like the message service is just a plain Java object that performs a single responsibility. Third, when one class directly creates another using the new keyword, we call that tight coupling. Tight coupling works for small programs, but it's a problem in larger systems because it makes the code less flexible. And finally, dependency injection is the idea that solves this. Instead of creating dependencies manually, we let a container provide them for us. That's the direction we'll move toward in the next lessons. 8. Discussion question. Here's a question to think about or discuss together. If we wanted to change the way the program gets its message, for example, instead of showing "Hello, world," we wanted to read that text from a file, a web service, or a database, how would we do it with this design? Would we need to modify the main application itself? This question naturally leads to the next step, where we'll learn how to decouple classes by using interfaces and, later, how to let Spring Boot manage those dependencies automatically through dependency injection.